Hey, welcome. This is Saurabh and the channel is So Code. Today we'll be solving LeetCode question number 54 called Spiral Metrics. This question has been featured in top MNC's interview and will test your iteration and edge case skills. So without wasting any time, let's get started with the video. Okay, so let's go through the question. So we'll be given an M cross N matrix and we have to return the spiral order of the matrix. So by spiral order, what do we mean is, let's say this is the 2D matrix given to us and we have to return elements in 1, 2, 3, 6, 9, 8, 7, 4, 5. So the output array will look something like this. So we have to return a 1D array that will contain elements in this order. So hope you have understood the question. Hope you have understood the problem. Now let's try to solve it. So let's say we are given this 2D array and we need to print the spiral order of this 2D array. So how we can do this? We can actually try to break this problem into sub problems. So let's see what will be my first sub problem will be. So let's say we are given this array. So my first sub problem will be, I need to somehow print these boundary elements of my matrix. Once we have printed all the boundary elements of the matrix, now what we can do is we can consider this inner matrix as my matrix. Okay, once we have considered this inner matrix as my matrix, what I can do is I can do the same thing, that is print all the boundary element of my this submatrix. Again, what we can do is we can consider this inner matrix as my submatrix, and then we can ask our function that what will be the boundary elements of this inner matrix. Once we have added all the boundary elements of the answer array, we'll actually get the resultant array, what we are looking for. So first we need to iterate all the boundary elements present in my first submatrix, and then a second matrix and third matrix and so on. And we'll add those elements to my result array and we'll get the spiral order we are looking for. Iterate over the boundary of my, basically how we can iterate over my first boundary. So to iterate over any boundary, what we'll need four indexes. Okay, we'll be needing this top, we'll be needing this top element index, and we'll needing this left. Okay, and let's say we'll needing this bottom, and we'll be needing this right. Once we have these four indexes, we can iterate over it. How we can iterate? We just have to iterate from left to right. This will be top to bottom, and this will be right to left, and then this will be from bottom to top. Okay, so having information about these four index, we can iterate over the my boundary element. So one concern you may have is, what about these elements, because if you see, this element will be visit covered in this iteration also, and this element will also be covered in this iteration. So we can actually manage this. Let's see how we can avoid this duplicates, basically this three duplicates, or for that matter this four duplicates. So because we'll only be needing to add these elements to any one of the subarray. Okay, so basically let's try to iterate, let's try to write the basic iteration how I can iterate over this first boundary. So let's say what will be my top index initially. My top index initially will be let me call it as top. My top initially will be 0. What will be my left initially? My left will again be 0. Okay, and what will be my bottom index initially? My bottom index initially will be nothing but basically it will be the size, like row number of rows in the element will be my bottom. So let's say number of n is the number of rows, and m is the number of columns. So this will bottom, my bottom will be n minus 1. And what will be my right right index initially? Right index initially will be the number of columns. So number of columns is m, so it will be, let's say, m minus 1, because it's a zero base index, that's why we are doing minus 1. Okay, so now once we have these four information, we can iterate over the my first boundary. How we can iterate over my first boundary is, let's try to first iterate from left to right. Okay, so how we can do this is, we just have to basically uh, run a basic for loop. uh, we have to run a for loop. Okay, I'm really sorry, let me reduce the size. Okay, so what we can do is we can run a for loop. Let's say we want to run get over this first array, basically the topmost element. So I can run from left, and this should be, where should it go? It should go till right. So I'll just say from left to right, and that's it. So this will basically do, this will do nothing but this will give me the very first and very top iteration of my first boundary. Okay, I'll simply, let's say, I'll add it to my result. What I'll need to add, I'll have to, basically my top is fixed. If you see, my top is fixed, so I'll just add my metrics. So metrics, my top will be fixed, and what will be my column? The column will be changing from zero to, ranging from zero to right. Okay, so this top and left, top and I have added. So what this for loop will do? This for loop will cover my top element of my boundary. So let's say what we can do is we can basically copy this, and we have to basically run this thing four number of times, right? For all the four uh, elements of the boundary. So what we can do is, let me copy paste this four number of times. Okay, now I'll just change the position. Okay, so now where it will run, now we have to run it from top to bottom. But if you see, that we have already printed or added this element. So what we can do is basically we just have to uh, increment the top, so that my top will basically start it from here, because I need to run it from here. So once we do this, we'll do nothing but we'll increment the top. So now my top will start from here. Okay, so now what I have to do is uh, I have to run this from top to bottom. Okay, so what I'll do is I'll run it from top and to bottom, and what it will do, it will increment, and this will again, my I is changing, but what will be the basically the column of it? Column will be nothing but right. Okay, so I'll write it as right. R, I'm writing it, R means right. Okay, so this will be my I've iterated over the this part of my boundary. Now what I have to do is I have to iterate over this part. But if we start it from here, it will, again it will add this element twice, because this is 39 has been already been added by this for loop. Okay, so what I we can do is we can basically increment uh, our right. Okay, so how we can increment our right? Not increment, actually we can decrement a right to 1. So once we decrement it, my right will become here. Okay, so what I'll do, decrement my right. I have decremented my right. Now what we can do is we can iterate from right to left. Okay, so we can just iterate from right to left. What will be my right? Right will be R, and it should be where this, like this should be greater than or equal to left, because we are iterating from left, and we need to decrement our value, right? We are reducing our column number. So what will be my, okay? So we have to add here is, now what we can add here is, we just have to add my bottom and I, because we are in going through the bottom and I. And next what we can do is we have to iterate from top to, basically bottom to top. Okay, so my this array I can iterate from bottom to top. But here again the same thing, here we have already printed added 21 to our answer, so we can increment our bottom to start it from here. So not increment again, it will should be decrement. And once we have decremented a bottom, and somewhere I'm writing it as B, somewhere I'm writing it as bottom. So okay, bear with me. So what I can do is we I can simply iterate from bottom greater than equal to top, and I can decrement my I. Okay, so and here I'll just have to iterate from I, and this will be fixed because this is the left element. Okay, so these four loops, what my these four loops will do, these four loops will basically these four loops will basically print my first boundary. Okay, basically now I have printed my not printed, I've added all my elements, uh, these elements to my result array. Now what we need to do is we need to start it from here, and we have to do the same thing. But if you notice that we have already incremented my top, so where my top is pointing to, my top was earlier at this index. Now I have incremented it, so my top is pointing to this index. Again, if you see, I have already decremented my right. So where my right is pointing to, earlier my right was pointing to here, now it is pointing to here. Okay, now my top is here, my right is here. And again, if you check what is my bottom was, my bottom was, again I had decremented the bottom earlier. Again my bottom would have increased by, not increased, it would have been decreased by 1. Okay, so if you see, my top I have basically my this will have incremented my top, this would have decremented my right to this position, and again this would have decremented my bottom. So earlier my bottom was this, now my bottom would have become this. And again what we can do is we can actually in decrement our left also. Okay, so earlier my left was pointing to here, we can decrement it to increment it to point it to here. So my new now top has become this, left has become this, and my bottom has become this, and my right has become this. So what I can add here is I can basically decrement my left element here. Again, sorry, it should be increment, so I would have incremented it. So once we have traversed it, now we have already got this as new top, and we have got this as a new top left, and we should have got this as new top right. Now we have to basically run the same thing again without changing anything. So how many times we have to run this? Yeah, so now we have to run this for loop again. So this will basically, in the second run, what it will do is it will print my element from this part, basically this part. And again it would this say after running it, it would have automatically basically it would have pointed my top left to here and my bottom right to here. And again it will run it from this part to this part, and so on. And running this will give us our answer. But again, how many times we have to run it? If you see closely, here it will start running from here to here. But at this time, this would have been a top left, this would have been a bottom right. Okay, and this would have been a top left, this would have been a bottom right. So what we have to do is, now we can say is, if now in the next run my top would have actually basically this would have interchanged. So my top would have come here in the next run, and my bottom would have come here, which is not correct, right? So if you see at the half point of my array, my bottom would have gone up, my top would have gone down. And my, again, if it was a square matrix, my left and right would have also been interchanged. Okay, so what I can say here is run break this. Basically, if you see in this condition, if you see if my top would have increased, uh, like become greater than bottom, and or if my left would have become greater than right, if these two conditions at any time, if you see this condition, you just need to break it. Okay, so what I'll write here is I'll try to write this condition before every loop, and I'll run this till any of this condition would have breaked. So hope you have understood what I was trying here. And so now let's try to write the code with the same approach what we have discussed. Hope you are clear on the approach. Now let's try to code this down. I'll be using Java here. You can use any language of your choice with the same logic. Okay, so now let me try to get the matrix size, that is number of rows, number of columns will be matrix of 0 dot length. Okay, once I have the matrix size, as we discussed, we'll be needing four variable. One will be top. We can initialize with 0. Next element will be left. We can again initialize with 0. Another element will be bottom. Bottom will be n minus 1, and another element will be right. It will be m minus 1. Okay, now once we have the top left of the first boundary and bottom right of the first boundary, we can start iterating. Okay, so we need to iterate it. We'll be breaking it down at some point. So let's see. First, we need to iterate the very first element, that is in the given example, from 1 to 3. So from left to right, we'll be iterating from int I equal to basically from left to right. Okay, so this will iterate from left to right. So we'll just add my answer to my result array. I'll initialize it somewhere result array. So the stop will be fixed because this won't be changing, right? Only the I will be iterating. So as we discussed, uh, that we need to actually avoid the duplicates because this 3 will be again be added from 3 to 9. So what we can do is here is we can just increment our top. This will make sure it won't be added again. Okay, so what we can do actually do is I can just copy this 4 times for each 4 matrix which will be iterating. Not sure why it got submitted. Okay, so let me initialize the result array here. And result, sorry, it will be an array list, right, of type integer. Once we have initialized the array and once we have gone from left to right, we need to go from top to bottom, right? So we'll be going from top to bottom. So in this case, it will be the row number that will be changing. My column will be remain fixed as right. Okay, and now I have to go from basically we have to go from 9 to 7. So what we can do here is we can just iterate from right to left and increment our I, and here my bottom will remain same. This will be the I changing again. Here we could have decremented right to avoid the duplicate values and also to initialize my next boundary. And here we have decremented bottom. Okay, now I just have to go from right to left. Okay, in this case my row, this will be changing, this will be remain fixed. Okay, and we can simply do a left plus plus. Here it should be greater than equal to. Okay, now we can remove, I think I've added one extra for loop here. uh, we can return a result, but before returning we also have to add the case where it needs to break, right? otherwise it will run till infinity. So we'll write something like as if top has become greater than bottom, or my right have become greater than left, left has become actually greater than right. Okay, so what we can do is if anytime this condition is done, we'll break it. So I don't have to actually write it here. What we can do here is we can write it before start of every loop, so that it does array does not overflow and go out of index. Okay, I think yeah, pretty much it. This should work. This I'm printing from left to right. Top and I is fixed. This I'm printing from top to bottom. I in right is fixed. This I'm printing from right to left. Bottom and I is there, and this I'm printing from. Uh, okay, here this I should print it from. What we need to do is we need to actually, I think I've written this two times. Okay, so we need to print it from bottom to top, and this I left will be fixed. Yeah, that's it. Let me break it here also. If this it can break here, we can break it here. Yeah, that's it. Yeah, hopefully this should work. Let me try to run it. And yeah, that's it. Hope you have enjoyed the video. Please don't forget to leave a like if you have watched till the end.